Dear classic children, today we'll continue chapter number 3, that is matter from chemistry once again. Today we'll see the states of matter. States of matter. Okay, states of matter. Okay, and states of matter. So, on what basis there are different states of matter? As we have discussed, that matter is composed of tiny particles. Okay, they are composed of tiny particles, and these particles are differently arranged in different types of matter. Okay, in some cases these particles are tightly packed, okay, tightly arranged. In some cases, okay, these particles or these molecules are loosely packed. In some cases they are very loosely packed, and accordingly they give the states to the matter. Okay, so that means on the basis of the arrangement of particles in the composition of matter, so the states have been, or the different states of the matter have been made. Okay, so and those particles which you find arranged there in the particles are held together by means of a force between the molecules, and that force is called intermolecular force. Intermolecular force of attraction. Intermolecular force of attraction. Suppose these are the particles. These are the particles of the molecules of matter. So they are held together by means of this force of attraction, which is called intermolecular force of attraction. As I've told you, in some cases the force of attraction, I mean the molecules are tightly packed, so here the force of attraction is very high. In some cases it is loosely packed, where the force of attraction is less. Accordingly, they are arranged there, and accordingly they give the states to the matter. So here we find three different states of matter. Okay, here we find three different states of matter. Okay, they are solids, okay, then liquids and gases. Okay, solids, liquid and gases. There are three states of matter. Okay, so for here first we'll talk about solids, then liquid and gases, and here we'll also try to know the differences between the different states of matter. Okay, we'll have a comparative discussion on these states of matter. Okay, first we'll talk about solid. Okay, so solids molecules are tightly packed. Okay, here molecules are tightly packed. Okay, molecules are tightly packed. Suppose like this here, molecules are tightly packed here. See the number of molecules you see out here being tightly packed. Okay, so that they have a definite shape and a definite volume. Okay, definite volume. Okay, definite shape and definite volume. Either it may be a rectangular shape, it may be a circular shape, any oval shape, any such shape you can see here. You see it is a solid particle. I mean it is a solid substance like a dust. You see here you find the particles being tightly packed, giving a definite shape out here. You see a chalk, it also has got a definite shape because the particles out here are tightly packed. So that means solids have got the particles tightly packed, which give a definite shape and a definite size, and also a definite volume. Okay, so that your solids. Okay, then what is also there is that I've drawn the particles being arranged here in the solid. So this is how the particles of the solids are arranged. Okay, so number 2, the intermolecular force of attraction is the strongest here. Strongest intermolecular force of attraction here. Okay, what is there? Strongest intermolecular force of attraction. Since the particles are tightly packed, the force with which they are held, is the strongest here. Okay, that means, the strongest intermolecular force of attraction here in between the molecules, in between the particles. Okay, strongest force of attraction is there in between the particles here. Okay, and they do not have fluidity. They do not flow. They do not flow. Okay, the solids cannot flow. You see, chalk, book, whatever it is here, they cannot flow. Alright? Then they do not fill their container, container completely. They do not fill their container completely. They do not fill container completely. See, completely. They do not fill their container completely. You just bring something like, the container out here, container here, you see. You fill this with some marbles, okay, or anything you put out, a marble or, rock, stone you put out here. It cannot completely fill the container, okay, unless it is made into the powder. It cannot, completely fill the container there, okay. And another property the solids, have is, they cannot be compressed much. They cannot be compressed. They cannot be compressed. They cannot be compressed much. Okay, they cannot be compressed much. You see, they cannot be compressed. See, sponge is also, solid. But here in this case, solid can be squeezed. It can be compressed to some extent. Okay, but once you, apply the force to it, then it can be compressed. But after, when you release it, then again it will come back to the same shape and size. Okay, which means here your solids cannot be completely compressed or cannot be, compressed much here in your solid. Why? Because the only one point is there why all these things are there is the particles are tightly packed. Okay, it's very tightly packed, and the force of attraction between the molecules is very strong, which means strongest of all. Okay, so that's all about your solids. Then let us go to the liquid. Another one, liquid here. Liquid. So liquids have loosely packed particles. That is, particles are loosely packed here. Particles are loosely packed. Okay, particles are loosely packed. Suppose this is your container. So here you have put water. Okay, here loosely packed. Loosely packed. See, the particles here in the case of liquids, are loosely packed. Okay. Then they have a fixed volume but no fixed shape. Okay, they have a fixed volume. Let us say water. Okay, water, let us fill a bottle of having a volume of 1 liter with water. Okay, that means the volume of water in that bottle is suppose 1 liter. And in whichever container you fill it, okay, or you pour it, the volume will be the same. Okay, the volume will be the same, but it will not have the same shape. Okay, so it will possess the shape according to the container it is filled in. Okay, which means it has got a definite volume but no definite shape. Okay, definite volume but no definite shape. Okay, you just for example you see say there is a cup out here, and another one is your glass. Another one is your glass. Another one is your bowl. Okay, something like that. See, suppose you have filled this cup with water. Let us say the water is 200 ml. Okay, the volume of water out here is 200 ml. Okay, and you pour the water, the water which is out here, you again fill it here in the another container. Okay, the volume will be the same, that is 200 ml. Now again fill this bowl with the water which is out here again. So the volume will be the same again here also, 200 ml in all three cases, but the shape is different. So here whatever the shape that cup has got, the same shape the water will possess, and here whatever the shape it has got, the same shape the water will possess accordingly. Okay, which means definite volume but no definite shape. Okay, that's what you can see in the case of liquid. And number 3, that liquids can flow. Okay, it can flow. Liquids can flow. Liquids can flow from higher level to lower level. You see any river, you find the river flowing from higher level to lower level, because river you find filled with water only. Water being a liquid can flow from higher level to lower levels. That means it can flow. Okay, not only water, any liquid can flow from higher level to lower level. All right, and they cannot be compressed much. Okay, similar to this, they cannot be compressed much. They cannot be compressed much. They cannot be compressed much. Okay, then we go to number 3, or the last state of matter, that is gas or gaseous state. Okay, so in gaseous state you see the arrangement of particles. So here the particles are very loosely packed. Particles are very loosely packed. Okay, particles are very loosely packed here. You see, particles tightly packed, particles are loosely packed, but here very loosely packed. Okay. Suppose this is a container. You see any your container, any kind of bottle is shown out here. You find this kind of bottles there in the physics lab or chemistry lab also there. Suppose this is a container or bottle filled with, let us say, chlorine gas or any other gas, maybe oxygen and all. So here the particles are found like this, or is like this. Okay, particles are very loosely packed, very loosely packed, very loosely packed. Particles are very loosely packed out here. Okay, see here. Okay, so they have neither a fixed volume nor a fixed shape. Okay, here they have a definite volume but no definite shape. Here no definite volume, and no definite shape. Okay, neither a definite volume nor a definite shape in the case of gases. Why? Because the same thing, that is the molecules or the particles are very loosely packed in this case. Okay, and the force of attraction between the molecules is negligible here. It is what? Negligible in the case of gases. Okay, so that they can freely move. They can freely move in any directions here. So they lack any shape and no volume. That means they lack shape and volume. Why? Because the molecules are loosely packed. So these molecules are free to move anywhere. Alright, and gases can easily flow. Can easily flow here. It can flow easily. It can flow easily in any direction. In all directions it can flow. Gas can flow, or the part of the gas can flow in all directions. So here this cannot flow, but here they can flow from higher level to lower level, but gases can flow in all directions. Okay, and they can completely fill the container. They can fill the container. They can fill the container completely. Okay, they can fill the container completely. Wherever they are put in, they are filled in. Okay, they can completely fill the container. Okay, and they can be compressed easily also. They can be compressed. They can be compressed easily. They can be compressed easily. They can fill the container completely. Whichever container they are filled in, they can completely fill it. They can completely fill those containers wherever they are filled in, and also they can be easily compressed. Here you see, they cannot be compressed much. They cannot be compressed much, but they can be compressed easily. Okay, so these are the different properties of these three states of matter. So here, why all these properties, all these different properties in these three different states is all mainly because of the arrangement of the particles. In all these cases, the arrangement of particle is different. So here it is tightly packed, it is loosely packed here, but it is very loosely packed. So that arrangement only brings about such differences in these three states of matter. Okay, so I think today we'll do only this much, because you got to understand it. You need to go through it. You need to understand it. Okay, so for understanding more about it, you just go through the book also, side by side. All right, there are many activities given here. You please try these activities at your home and try to understand. So we'll do only this much today. All right, so thank you very much.